So now we come to the topic of dealing with limits involving a number divided by zero. In previous videos, in the last section, we talked about how to do limits involving 0 divided by 0. And so now we turn to limits involving a number divided by 0. Please check in the notes here for this section 2.4. Please check out those pictures, the graphs, to show you kind of what's going on graphically when we have a number divided by 0, the different possibilities. And that's going to be important to read through that and understand that stuff first before we get into our examples. So we're going to begin first with the left and right hand limits. Those are the only number divided by 0 limits we can do directly. Those are the only ones we can do directly. The other ones, as we'll see in the next video, actually takes kind of 2 steps. So here we're looking at the limit as we approach from the left. Well, first natural thing is, can we evaluate it? And we try to. And when we plug 2 into this, the top becomes 5, which is okay. The bottom becomes 0. And so we are dealing with this number divided by 0 limit. And so we know that since we have a non-zero number divided by 0, that this is going to be a vertical asymptote. So it's either going to approach positive or negative infinity for a left or a right hand limit. So at this point we know, because it's a number divided by 0 limit, that we are going to be either going to positive infinity or negative infinity. But we don't know which one. So what we have to figure out is, as x is approaching 2 from below, so from the left, value smaller than 2, what are the signs of the numerator and denominator? Because that's going to kind of dictate, as we're just almost to 2, what is the sign of the numerator and denominator? Because that will give us an idea of what the sign of the thing is. We know it's going to infinity, we just need to know whether it's positive or negative. So we check the numerator and denominator sign. If we plug in numbers just a little bit smaller than 2, the numerator x plus 3 is close to 5. And so therefore the numerator is approaching a positive amount. As x approaches 2 from below, taking on values a little bit smaller than 2, like 1.9, 1.99, quick check shows you that the denominator is negative when we take in values that are just a little bit smaller than 2. The denominator is negative. And of course, as we know, if we have a positive number divided by a negative number, then we have a negative number. And so the numbers of the overall numerical values are negative as we get close to negative or positive 2 from below. So therefore, we're going to negative infinity. Let's consider another example here. This time we're looking at the limit as x approaches 4 from above. So the right-hand limit of the fraction 2x plus 1 over x minus 4. Again, with any of these problems, our first instinct, our first choice is, well, let's see if we can evaluate it. Because if we can evaluate it, then we're done and we don't have to do any work. But turns out the numerator goes to be 9, denominator goes to be 0, so once again we do have this number divided by 0 limit. So we go ahead and say, okay, well, it's going to be either positive or negative infinity at this point in time. So we check the signs of the numerator and denominator as x approaches 4, taking on values a little bit bigger than 4. So in this case, 2x plus 1, if we plug in values a little bit bigger than 4, that's going to be approaching positive 9. All right, positive 9. So the values are positive, taking on values a little bit bigger than 4. And then the denominator, values a little bit bigger than 4, subtract off 4, well, that's going to be bigger than 0. So both the numerator and denominator are positive, and so therefore the limit is positive infinity.